Hi, I'm Nathan Gherkin,
And I'm Lauren Freeman.
and this is our presentation on parent-child snappers untangling the family tree.
So we are from Platinum Edge Solutions. We are a partner of Configura that started in October of 2018. So that's how many years now? 6 years?
Yeah, about six.
Wow, very nice. We've grown from 3 employees to 18. I think we're finally maxing out now. And we specialize in full PGC extensions. And we like to have fun and do some fun stuff around here. We do Kickoff, which we were doing this week actually. So we're gonna have some new pictures when we present this at CET Experience. We do a lot of team building. We dress up. We're silly. We have a good time. But we also know how to get stuff done and do it well. So introducing us individually. I'm Lauren. Hi. I've been a CM developer for over 2 years now, and I'm the resident child snapper expert at Pez. And it's not just because I'm the only female dev at Pez, I promise. Outside of work, I love to sew and I make a lot of costumes. Hooray!
And I'm Nate Gherkin. I've been a CM developer for just over 3 years. I am the resident doctor at Pez. And outside of developing, I enjoy playing video games and 3D printing. And these are just some of the 3D prints I've done.
Super cool. So getting into the actual meat of it.
So, to start, what are parent-child snappers? As of 12.0, it is now possible to allow snappers to exist on other snappers. Um, Child snapper functionality is almost the same as normal snappers, but they aren't present in BSP or a space. Um, and just in general, the owner snapper is the parent, and the contained snappers are the children. Um, this allows for a complex product structure while reducing any potential performance penalties. And it allows developers to use all the features of the snapper class while, while organizing things into a sort of sub-object system. The best part of all this, the parent-child snapper functionality is already baked into the snapper class. So all any snapper has to do is opt in to be able to use the functionality of parent-child snappers.
So what can they do?
Well, as we know, storing snapper references is a big no-no. So because of that, there is a link from parents to children, and this link is very powerful. Um, in theory, um, parents can be children of other parents, and children can be parents to other children. This means that the family tree can be as big as you want. Um, Parent snappers always know who their children are, and child snappers always know who their parents are. So because of this, any snapper in the family tree can know any other snapper in the family tree by looking recursively through their parent-child relationships.
Mhm. Since snappers are usually an individual thing, it can be difficult when you need to reference another snapper for any sort of information. But because all of these snappers are intrinsically related to each other, it's super easy to look up any other snapper's information for a variety of purposes.
So, what can parent-child snappers do? Um, Big one right out the gate is you can place several snappers at once. Think typicals like this. Um, Instead of having to place multiple snappers with multiple clicks, you can click one button, click to place, and you've placed an entire typical with multiple snappers. Some other functionality, they can share a part number stored on the parent, or each of the children could have their own part numbers. And this is the same with properties. The children can control their own properties, or the parents can control the properties, or the parents can retrieve the info from the children when getting the properties. In the case of typicals, the parent would essentially be an invisible snapper that's used as a holder for the child or the child snappers. So just as an example, imagine you have a client that has a line of power beams, surfaces, dividers, storage, etc. A user could place each individually, as I kind of already mentioned, or again, as I already mentioned, you could place one and have an entire desking pod in very few clicks.
Mm-hmm. And we use partner numbers as an example here, but that can really be any sort of part information across any of it. That's just an easy example.
So what else can they do? We kind of already mentioned this, but properties can be parent or child control. The parents can hold the properties and the children can ask what they should be. Think stuff like finishes, height, etc. Or the children can individually hold properties. And this can go as far as the children notifying the other children when their properties have changed.
Mhm.
More of what you can do. Child snappers can be created, destroyed, orphaned, or adopted. Just as some examples, a spacer surface can be added or removed to a table when it's stretched. Reordering children for handedness change can destroy all the children and recreate them. If a child is disconnected from a group, it can be orphaned, or if it's connected to a group, it can be adopted in. And the possibilities of uses for this are pretty big.
Mm-hmm. I think that's one of the main functionalities of the whole parent-child paradigm is there's a lot of customizability here.
So, when are good situations to use child snappers? So, as we kind of already mentioned, typicals is a good one. Also, modular furniture, clone armies for the Galactic Republic, and anything complex enough where it's easier to represent as multiple snappers.
Yep. But when should we not use child snappers? Which I think, like I said, I'm the resident parent-child person at Pez. And when people ask me questions about parent-child snappers, usually the question is just, should I use them or not?
Yeah. So some good examples of when not to use parent-child snappers are anything that cannot function on its own. So think stuff like supports, panel skins, electrical setups, armor for said clone army. You don't want things that you're not going to normally place in the world to be, or on their own, to be part of a parent-child snapper system.
Mm-hmm. And there are always exceptions to this stuff. There isn't like a good rule of thumb for definitely always use it in this case, definitely don't use it in this case. And sometimes maybe you do have something super complex where you need that snapper functionality on something that is wholly dependent on something else. But for a lot of instances, like for example, on these shelves here, they have these brackets, and those brackets are only ever going to be in that one place. They don't really have a lot of properties. You don't need them to move independently at all. So there's no reason why that would have to be a child snapper on the shelf. But in theory, you could have each of these shelves be a child snapper of the whole setup. And then you could select one of those shelves, drag it out. Now it's a whole separate thing. If you wanted that functionality, you could with parent-child snappers. It's really just what the end goal is. So we've talked about conceptually what they can do and why you would want to use them, but let's get into, okay, we've decided I want to use a parent-child snapper. What do I need to know to get started with it? And this is already all baked into Snapper. So as we say, you just have to opt in. So here are some of the methods that you're going to be using if you decide to use parent-child snappers.
So first of all, accept adoption. Straight up, does this snapper allow child snappers to be adopted? By default, this is false. So if you want to use parent-child snappers, you're going to have to change this to true if you want to be able to adopt child snappers.
Mhm. And since it passes in the child that it's checking for, then you can conditionally choose what types of children you're allowed to adopt.
Child added and child removed. These are like any other method that seems similar. Anything you need to do when a child is added or removed to the family tree. These methods are invoked when a child is added or removed. Yeah, best place to do updates.
Mhm, mhm.
Parent changed, just like child added or removed. This is for the child for if the parent is changed, what do I need to do when that happens?
Mhm. And this can be really helpful when you have properties dependent on the parent, of course, then you're going to have to make sure those are all in sync. So parent change is a good place to do that.
Parent and root parent. So parent finds the immediate parent of a child, and root parent finds or uses parent recursively to find the top level parent of the family tree, the matriarch, if you will. One big thing is that um, if a snapper has no parent, then parent will return null. Um, so if the matriarch calls parent, it'll be null. But if the matriarch calls root parent, it will return itself. So this can also be very useful for determining that matriarch in cases where you might need that. Next is child snapper. Simply put, is this snapper a child to a parent snapper somewhere?
Pretty straightforward. Basically, just is parent null or not, but that's kind of a nicer way of putting it, is child snapper.
Child of and any child of. Child of will tell you if a snapper is your direct parent, and any child of will tell you if a snapper is um, a parent, grandparent, or any level above.
Mhm.
Has child snappers will tell you if a parent snapper has any children. And then children will list out all the children of a snapper. There's a recursive flag. By default, this is false. And when this is false, it will only list the direct children. However, if you set this to true, it will recursively search through and list any snapper that is below that snapper on the family tree
Mhm.
that is directly related, of course.
I forgot to mention this earlier, but some of these you notice are bolded because they're ones that I personally use a lot when I'm using parent-child snappers. Children, I'd say, is used basically for everything. Anytime I check for anything, I have to grab my children to apply something to them.
And if you want to see more of these functions, you can look at cm/core/child snapper functions.cl.
Nice. So that was a whole lot to dump on you. And unfortunately, we have more to dump on you because we're going to be talking about relationships.
Yes.
Yay. You didn't think you'd be talking about that at a tech conference, but it's always important and applies to everything.
So there exists on the parent an object called a snapper relationship that specifies how children should behave. This can be used to specify a whole load of different things, such as, is a child selectable? Is it movable? Do you want to show the child's quick properties? That sort of thing.
Mhm.
So first of all, relationship. This just simply returns the type of relationship for a child snapper to a parent. You call this on the parent.
Yeah, the parent is the one that sets what the relationship is. The child can check what the relationship is with parent relationship, but it is set in the parent. And you'll notice that in relationship, it passes in child. So you can customize what relationship you have with each specific child if you need to get really granular with it. I personally have never had to do anything that intense, but you can if you need to.
And going the other direction, parent relationship. This is for a child to essentially ask a parent what its relationship is, if any.
Mhm. So here are some of the methods that you can customize in your relationship.
So redirect selection to parent. This indicates whether or not a child snapper should be selectable. If true, you can click on a child snapper specifically. If false, you will select the parent instead of the child. By default, this is false. So if you want to be able to select the children specifically, you'll need to set this to true.
Well, it's the other way around, but close. If the method returns true, then clicking on the child redirects the selection to the parent. So this is something that I usually have set to be false because, even if I don't want the child to be its own specific thing that can like move independently, if I want to have its own quick properties, for example, I want to be able to select the child so that, its own quick properties will show up.
Allow user move child. This indicates whether the user is allowed to move child snappers. If set to true, you'll be able to click on and move a child snapper, and this is how you would orphan or adopt child snappers into the family tree. By default, this is true.
Mhm.
Redirect left drag to parent. This indicates whether a child should be dragged when you click drag something, or if it should drag the parent snapper, i.e. moving all the snappers in the family tree.
Mhm.
By default, this is false. So if you want your entire family tree to move as one all the time, you're going to have to set this to true.
So it's kind of like the difference between like a single select and a group select. Even if your stuff isn't literally connected together with connectors, it'll still behave that way.
And allow user release child. This basically allows the user to orphan a child from the family tree. Basically, can you take this child and remove it from the family tree?
Mhm.
Allow user delete child. Same thing as allow user move child. Can you delete this child from the family tree? Simple as that.
Mhm. And this one I have another funny story about. So I had a situation where I didn't want you to be able to remove the child independently of everything else. Like I didn't want you to be able to have this typical with that child removed. So I set it to false because I was like, well, I don't want my user to delete the child. But in that situation, I had it where the parent was just this invisible container for all the children. So then there was no way to select anything and delete it because I made it so you can't delete the children. So I'll show later how I kind of worked around that, but that's something to be aware of.
Include child parts. Simply put, do we collect the parts from the child snappers, or does the parent control all this? By default, this is true. So if you want everything to be contained under one part number, you'll have to set this to false. include child invalidation. This is any sort of invalidations from the children. Do you want the parent to grab those? By default, this is true. So if you don't want that, you're gonna have to set it to false.
A lot of these are things that I don't usually change at all, but if you want to, like propagate your part tags or your categories or space volumes, you can mess with that, but I found the default is just fine. And that's most of the things in Snapper relationship, but there are a couple more. So if you want to see more of them, if we haven't bored you enough already with the big list of them, you can go to CM Core Snapper Relationship CM for more. So I've talked about a couple anecdotes of me working with child snappers and some issues I've run into, but I'm going to show some really specific examples for you guys. And this is one that a lot of us have run into, so I think it's important to talk about. So, in this instance, we have it where, you have a typical and it has a handedness. And when you want to change your handedness, which is basically flipping where your children are, we basically kill all of our children and then bring them all back in a different order because that's just easier than trying to like move them around and like make sure everything's aligned again. So that's what we decided to do. But this was something that you would choose in the child's quick properties. And basically this would break undo if you just like kill yourself in your own quick property, because then when you hit undo, it would try to bring something back that doesn't exist anymore. So basically, we have to do some special shenanigans with our space in order to remove all of our children without destroying undo. And I know that undo problems are a really big thing with child snappers since you're storing a snapper reference. Just intrinsically, that's how they work. But most of the issues we run into have been fixed by doing this sort of thing on the parent. So the child isn't the one actually killing itself. It's telling the parent to run this to kill all the children. Very morbid presentation, I'm realizing. So yeah, if you're adding or removing children inside of quick modify, be sure to call attached to space volume at the end of it. I think this kind of speaks for itself though. Another issue that we ran into, and this is another like really weird one that I can't really explain. We submitted a bug fix to configure forever ago, but I don't know what the status is on that. So basically, we found out that when we were inserting our typical that had all of its child snappers, like it's supposed to all go out at once. But when you first click it and you're moving it in before you drop it into space, the children just wouldn't show up sometimes. Like you'd only have a couple or it would only be the parent. And it was really weird. So basically, we just had to make our own insert animation that very ineloquently, basically just what it does is it invalidates the 3D for the first couple moves of your insert animation. And there's not like a better workaround we found. This isn't like that pretty, but if anyone has a better solution, let us know. But I thought I'd bring that up for any of you guys in case you run into it yourself and you're like, I don't understand what's going wrong. It's just a core thing that we've run into pretty consistently. So there you go. Now, we've been talking a lot about hypotheticals of how in theory you could apply this. And so I prepared a little demo to show you how it works actually. And we're going to go through in some of the code and show you more of the stuff. So let me get that pulled up for you guys. All right. Is that still showing on the Zoom? Hopefully.
Yes.
Okay, wonderful. So we have this little private office typical. And this is another instance where the parent is just an invisible container, essentially. And each of these little columns, modules, is a child. And as you can see, this is the handedness thing I was talking about. You have your left and right handedness when you click it. What happens here is all these children are being destroyed and then rebuilt. And you can see how that works pretty intuitively. Another thing that you can do here is this office laminate is a property on the parent and not the child. So if I change it, even though I only have one selected here, when I select it, it's applying to all of the children. Even though I only have this one selected and I'm doing this one quick property, it automatically propagates to all of these because this is a parent's property and not the child's property. And you can do a lot of really crazy stuff with this. This is just a really bare example to kind of give you an idea of some of the things you can do. Now you'll see in our bill of materials here, I can bring it over. All right. That this whole thing has one part. And that is because this is being ordered by the parent and not the children. But you'll notice that there are these individual properties that belong to the children, like the shelf pane is only on that one little module, the tower laminate, obviously only on the tower. And the way we do that, basically the children all pass along its option lookup information to the parent, and then the parent actually fills everything in with the information from its children. And I can show you that in the code real easy here. So here is our typical office. This is the parent. And here we have this is where the main options are getting filled in here. And this is our own method, but I think it's pretty easy to extrapolate for whatever you guys use. And we basically just make this little option lookup map where we call the children's main options, which is basically just going to return a map of all of these option lookups. And we can just search for the keys that we want, add that to our parts environment, and that's it. It's pretty straightforward and easy just because we can easily search through our children here. And like I said, we're using this children method a lot in a lot of our stuff. So how we actually make children, I think that is something important to understand here, is we've made this make new children method. This is not something baked in, but basically all it does is this method gets called at initialized work surface, and there's nothing really special going on here. So we make each of our different little modules here, and we pass in the office, what we want to be the parent, into it. And that is because we can see over here, I hope that's not too cramped over here. I've made this constructor for the modules, which passes the parent in. And then you just call this little change parent method, and it just sets the parent. And that's it. Now you could, in here, make them all and then just set the parent separately. But we found some instances where there was some information that you needed to know during construction about the parent. So it was just easier to make a constructor that passed the parent in. But you don't even have to do that necessarily. You can just set it separately in here. And then all you really have to do is we set our position so that they're all in a row nicely. And that's it. Since you set the parent here, these automatically are now included in the little children method. You don't have to add it to any sort of special children list. As soon as this parent is set in the child, it knows to be included. So there's a lot of stuff that you think would be overhead you'd have to worry about, but you actually don't have to just because it's built into Snapper already, which is really nice and really handy. So another thing that I wanted to show you guys is what I was talking about removing children. Oh yeah, and you can see here's where make new children happens. It's literally just, if I don't have children yet, I call it an initialized work surface. Nothing special here. But here's that child removed method. Basically, because you can't remove a child, it can't just be gone and the rest of the typical is still there. So if you use a remover animation on a child, we have this little end it all method. Now we toyed with a couple names for this, but murder suicide didn't really get through the code review, unfortunately. So we call it end it all. And all that happens is you just do this undoable remove in the space on the office. And since the children are all in the office's space, It just gets rid of everything, which is really nice. So I can show you that working here. So I got my remover animation. I'm going to target just this one, but now all of them disappear, even though I only targeted the one. And it's as simple as that. One last thing I'm going to show you guys is the relationship, which I realize I want to cite here, but I'm just going to bring it to this main buffer. That's easier. And it's really this simple. Like you just extend snap a relationship, you make your own relationship. I call it a bitwise office because I thought that was a cute name. So we have our bitwise relationship, and you just set whatever you need, true or false, whatever you want. We kind of already went over how all these work, so there's not really anything fancy here, but it really is that simple. And then in the parent, you're just gonna return bitwise relationship and you're set. Your children are gonna work exactly how you would like to. So this can be as simple and as complicated as you want at the end of the day. And it just kind of takes some looking around for what is available. You know, I've had people come to me with questions about, oh, I have this parent-child snapper thing I'm doing, and my child's not working right, and I can't figure out why. And I was like, oh, what did you set this method to in the relationship? And they were like, oh, I didn't even know that was a method in the relationship. So I would recommend looking through Snap a relationship just to see like what things can you do, what things are available to you if you're trying to use this. That is all for my little demo. So we can get back to our presentation. Come on. Jeez.
So, in conclusion, parent-child snappers are fun for the whole family.
Yeah. And then we'll open it up for questions, but this is just the recording. So if you guys do have any questions, then you can send us an email. There's our contact information. There's our pretty faces. And thank you so much for coming to our presentation.
Thank you.
Yay!